Yeah, hi everyone. I'm Kirill, and I work at the company called Nethermind. If you are confused, it's supposed to be so because actually this is different Nethermind, which developed the client for Ethereum, which is the fastest currently and the most used. Can we switch back for a moment? Is it possible to? Oh, yes. A few words about myself. I worked in the field of AI since 2017. And as Dan mentioned already that before that it was static modeling. Then we used TF, IDF, bag of words. Then attention is all we need. And BERT changed everything. Then GPT, etc. And basically, I used everything of it in my work. And by 2021, I already was full of AI, and I felt like I want to do something new. And the most interesting and challenging was Web3. So I took a sabbatical, and for a year, I've been learning Solidity, EVM, Ethereum, data indexing, etc. Then I worked at ChainStack, RPC node provider, and developed indexing solution, ChainStack subgraphs. And then I'm at Nethermind, working on the projects, finally on the intersection of AI, data, and Web3. And at Nethermind, there are multiple initiatives related to this intersection. And Nethermind does research in ZKML space, also developing agentic framework and DA layer for AI agents, and the thing that I will be talking about today. So, roughly 6 months ago, we started exploring the question: can LLMs find securities issues in Solidity smart contracts? And there is a tweet from Vitalik regarding the most excited applications of AI to Web3, which are kind of AI-assisted formal verification or bug finding. And this is important. It's kind of biggest technical risk is a bug in Ethereum. So basically, for any chain, if there is a bug, the chain can, if chain is finally decentralized and kind of immutable, so it's a critical problem if a bug has been found. But there are particular challenges that basically Solidity is a niche language, so the results are supposed to be worse than compared to Python or Java or like any other mainstream language. Also, their vulnerabilities are actually can be complicated. So it's the task is actually different compared to code generation. And in the code generation, we from the beginning we see that LLMs are applicable and they are getting better and better. And also the other one more challenge regarding the basically auditing, the findings that the auditors can find, and then when they are starting to discuss them, we notice that they actually cannot agree on a lot of them. So if there are some critical bugs, okay, everybody agree with that. But I would say 70% of the bugs are arguable if this is actually important, or it can be exploited effectively, etc. And it's interesting to show how it was 6 months ago, how the landscape looked like, because the idea of making AI-based auditor was here right from ChatGPT appeared, and it's basically easy. You can run ChatGPT API, send the smart contract, ask to find vulnerabilities, and you have some output, which basically makes no sense, but there are some prototypes on the market that do exactly the same thing. And 6 months ago, it was a few landing pages with AI auditor that doesn't actually exist.
there were some SaaS platforms, like you can log in, you can send your smart contracts or a repository, and then you are getting offered to purchase an actual audit. There is kind of nothing. Or some of them were utilizing Slither and basically showing its results combined with something not really clear. And finally, there were a couple of papers from auditing teams that explored these opportunities 2 years ago or even 1 year ago, and did the benchmarking, and finally came to the conclusion that actually it's not applicable currently, so it doesn't work. And the interesting thing is that experts in any field, when they try using AI for their field of experience, they feel that, oh, okay, it's too stupid, it cannot be used. And then they bring this feeling, and they also distribute it. But actually, the AI is developing, and it's progressing pretty quickly. So we started with experimenting. So first of all, that was interesting to do fine-tuning. It's we started looking for a data set for it, and basically it's extremely niche thing. So the only data set that was in some ways applicable was smart bugs curated. The repository is related to benchmarking the static analyzers, basically. And there were about 150 smart contracts annotated with this type of annotation. You can see on the bottom, yes, report, front running, let's say. And we did some fine tuning there, and you can see the model on Hugging Face that has been uploaded 6 months ago, and after that, only 3 users deployed something related to Solidity. So it's not so crowded space, and after we started doing that, we realized that the data is extremely bad, and you have to do a lot of cleaning of data, as usual in data science. And but basically, it showed some performance in terms of before fine-tuning, it didn't find anything. Then after fine-tuning, it started showing some results. In some cases, it showed correct line. And we started writing prompts for that, and prompting basically improved the results a lot. And then we, in the beginning, there was a simple test with GPT-4, the first version, and before any prompting, before cleaning the data. But at the point when we started doing kind of more detailed research, we get back to GPT-4, compared it, and GPT-4 just drastically outperformed any fine-tuned LLM on any clean data, with any prompt, no comparison can be done. So we just switched to closed source models, and never got back to open source. And what was important, the actual findings for us is that so the context is extremely important. It's without good examples in the context, bad examples. So basically, we are not actually utilizing the code understanding as we are utilizing the instruction following capabilities of LLM. And that's why the models which are much larger with much better instruction following capabilities are showing much better results. And also annotation style is important because LLMs are like working with the sequences, and the default annotations like just doesn't help at all. So we end up with the annotating each line with a number, and then the result as a completion. We are asking to provide the number of the line with the vulnerability. So last interesting thing here on the slide, you see the context. We had the context on both of these experiments on the bottom, and you see the confusion matrix that has been changed, just tuning up the context. So for a person, for like kind of a human who is reading this, it looked pretty much the same way. Like there is some description, there is some code and annotations, but when we start in specifically improving the description, the context quality, the results changed just a lot. So it's two different pictures. When we started getting good results when the LLM is actually outperforming the static analyzers on these vulnerabilities that were kind of typical. Like you can say at least a type of vulnerability, like a front running or reentrancy or arithmetic. We started showing to real developers and asking like for their feedback if this is helpful for them to have kind of better version of Slither, and people are actually don't really like the false positives that Slither shows, and the answer was kind of it's nice to have, but we are not ready to pay for it at all. So we already have Slither. We can look at this long list of findings, but like we don't need anything on top of it. But what we need actually is to finding the discrepancies between the code and the specification or description or the like natural way of how the contract is supposed to be operating. And to do that, we cannot even invent a type of vulnerability that we are trying to detect, to localize. And this is extremely different thing, and it is much more different directions can be found in this way. And we switched to extremely different approach. We stopped trying to detect particular types of vulnerabilities, and we started doing additional steps like critic at the end, like combining outputs of the same scans, planning in the beginning, adding descriptions, examples, etc. And in that case, after we started showing this, so we didn't tune at all. Like we just built different structure of how to work with the code. And the feedback of one of the notable users was like, okay, there are 6, I guess, findings, and we are looking at them together. And he says, okay, the first one, it's not really important. The second one is kind of, okay, it's by design, it's okay. This third one is false positive. And the last one was, oh wait, this is important, I actually never thought about it. And it was the moment when we kind of got this particular understanding that LLM in the right architecture used can give something that developers are not actually seeing. So it doesn't mean that they would not find it if they would spend like hours on reviewing code or testing again and again, but developers are not actually focused on that. Developers are focused on the development. But LLM does this in in 2 seconds, basically. So the value appeared, and we started doing more research on this topic and getting better and better results. But the next big change that can basically, if people are not using this in day-to-day, or especially in some specific use cases where the intelligence, not just like a level of text comprehension or generating text in correct styling, etc., but they think that people like the CEO of OpenAI are calling like intelligence, like this model is actually smarter. So they are not even explaining what it means. But it looks like when OpenAI 01 preview came, that we actually saw how these models are like they have reasoning, they have planning. So you actually see how these approach the problem, and it says like, okay, reading first step, reading the code. Next step, analyzing this function. Next step, finding these types of vulnerabilities, combining, getting the output, then checking that it is correct. And so it's the whole new approach to this problem. And this is the tweet that was just in the same day from Chief Security Officer of Polygon, who said like it's surprisingly good, right? From initial testing, and it's like better than any static analyzer, and basically it can like good enough to become a mandatory step in audits. And I couldn't find the other tweet there. I guess he also, or some other auditor, yeah, thank you, said like, oh, these steps, which are shown in your UI of ChatGPT, are surprisingly look the same as the steps I am doing when I am auditing. So the level of intelligence became actually like on the different level, went to the different level, next level. And we just switched our current setup to the new model. And what we got is that the feedback from the customers changed from the like half of the findings make sense. Sometimes this is really important to like, okay, yes, it should be kind of mandatory step in our process. We should call it on some releases, or if we go to the audit or are preparing to the audit, we actually have to first do this kind of pre-audit and start fixing the things that it's shown already. So we don't need to wait for auditing to start fixing bugs, and we don't actually need to pay for the auditor time while they are looking for the bugs that we can find via this tool. And in this, this was the kind of change from the like it works sometimes well to the state when like it works pretty reliably, and it should be used because it saves you time, money. And okay, what were our conclusions? What is important currently on the current state of technologies? So first is definitely using the advanced reasoning capabilities models like O1 Preview and O1 Mini, and they can sometimes they can find different bugs. So sometimes, let's say, Mini can find something that Preview didn't find. Implementing an agent-based approach with planning, also the step of criticizing because it can help filter false positives. And also, like again, the extremely important part is related to the context, because without the context, people, like even auditors, cannot agree on the importance, or like if it is true positive or false positive. So the context still is extremely important thing. And how we see how it will work in the future. Yeah, basically, there is one thing that I should have said. I guess the most important thing in the entire deck that I missed is that in October we actually found a major bug in the code that already has been audited by professional auditors. And actually this was the last step, the last big change that happened, because at this point we already understand that if we are not applying this tool, even if the human, real people auditors are doing their job, we can still miss something that can be found in the future, potentially by hackers. And at this point, we already don't think about if it is kind of useful. So the question of the entire deck is like definitely yes, but we actually didn't think that we will get to this point so quickly. And now, just to describe how we view the future of these tools, is that basically on the previous architectures, these LLMs block was the main block on in the middle. But we think that we are going to the structures where the AI agent, which is like auditor, is operating in pretty similar way as the auditors do now. Like they can use the tool that we already have. They can it can also use static analyzer and, for instance, filter the findings with the context. It can run fuzzing. It can even do formal verification, or like any other tools that auditors do. And it can do it basically like there is no particular restriction to do it better. And like the final like answers what LLMs are useful for. So code auditing, already finding bugs missed by human auditors. Static analyzers use, we already implemented this, and it actually does. And it also gives the extra description for the bugs. Fuzz testing, it is in development, and we see that basically it's already shows promising results. But there are a few more things like proof of code writing, formal verification, or other tools which are looks really promising. So like last thing, finally we packaged it as a product. So the full functionality that I described here is available on auditagent.nethermind.io, and like it is based on like a lot of API calls to OpenAI and Anthropic models. So it's not free, but in this Telegram group that you can join, I will share today or tomorrow a special coupon code for like using this for free for some period of time. And we will be happy to get your feedback on it. If you have any questions, I'll be happy to answer.